Hello, everyone. Again, it's Bryden Templeton, and I'm back with another video. I'd like to say back by popular demand, but it's definitely more like back by internal demand. So today I'm going to be talking about some weather stations and what we're doing with that. They're a very clever title that I cannot take credit for. What are they good for? So yeah, we're going to be chatting about measuring soil moisture and water-driven yield potential, why we're doing that, how we do it, and what it means for your guys' operations. So appropriately enough, I actually started this presentation on May 20th, which was our big rain day in West Central Saskatchewan. So yeah, I just took a little bit of footage of kind of what we were seeing on the radar at that point. I really hope that we don't refer to this as our rain day by the end of this season, and hopefully it's one of our rain days. So yeah, we can see a little bit of footage on the radar there, and here we have just a bit of a summary of that rain event in millimeters across our geography with regards to where our some of our weather stations are. So yeah, we can see there's definitely a spectrum of rainfall. Across GMAX, we definitely, everyone got a little bit of rain, but there was definitely, I would say it ranged from probably half an inch to, in some cases, over 2 inches. But yeah, that's just a bit of a taste of, kind of the data that we can get from these stations. So a bit of a overview of the presentation today. Going to spend a little bit of time, just some introductory thoughts about water and crop production in Western Canada, and how we think about the water that's available to our crops. What are we measuring? So a little bit of discussion on precipitation versus soil moisture, how we are measuring it, so a little bit of information regarding the hardware, and we'll spend a little bit of time on the software and what we can do with it. And lastly, and definitely most importantly, why are we measuring it, and how do we apply that data? So I always think this is kind of a fun place to start when thinking about the importance of water and crop production and the somewhat harsh realities of where we farm in Canada. And so many years ago, a beautiful neck-bearded John Palliser made his way across Western Canada and reported back to his superiors and said, do not come here. This is more or less an arid desert, and no one is going to be able to produce a crop here. Fortunately or unfortunately, our ancestors didn't listen and showed up here many years later and settled the land and went to work growing crops. So we can kind of see that triangle in this picture. This is, I think, just an image I've stolen off Wikipedia on the John Palliser article. But here's just a little bit of a different view of it, but we get the same effect here. So this is some average rainfall across Western Canada, and you can just definitely see that where that Palliser triangle kind of is. And the reality is we receive not a lot of moisture each year, and more often than not we find ourselves limited by that reality. Yeah. So it was never my intention to start this presentation off with like this air of negativity, but these are some hard facts that of growing a crop in Western Canada that I think we should be aware of, and they should be kind of at the front of our minds when we're making decisions. So what we're looking at here is some Statistics Canada data of gross farm revenue versus net farm income, and the trends we've seen over the last what are we at, like 90 years. So it is not getting any cheaper to raise a crop in Western Canada, and it takes a lot of investment to receive a similar return as we have in the last 30 years, at least according to this data set. So this makes me wonder, should we be looking at options and examples to try to limit that gap when it makes sense to limit that gap? So we know we don't have the same opportunity to raise a crop every year. We are at the whim of something that has a huge impact on our production that we have no control over. So I wonder, is there room to be able to adjust to the conditions that we receive in a growing season? Yeah, so here's a few more comments that I would have when thinking through water and its effect on crop production in Western Canada, and how we think through it. And you know, some of these might be a little bit tongue-in-cheek, but like right off the bat, it's pretty important for plants. For a whole host of reasons that we won't get into. I feel like we've got buy-in on that. We know water is important for just an incredible amount of functions in that plant. It's also pretty important for talking. I sometimes wonder what if we made a pact that in rural Saskatchewan we weren't able to talk about the weather for a year. Holy, what will we chat about? It is it serves as the foundation of just small talk over all the time. Like it's incredible. Sometimes it falls from the sky, which is just unfortunately continues to be something we can't do anything about, and looks to be like that'll be the case for many years. Timing, we know timing is super important in terms of crop production. We know a rain in the middle of a nice flowering canola field can be very important, whereas rain in the middle of August is a lot less important for our production, or obviously for opposite reasons. More often than not, we would like more. We've kind of discussed that in farming in the Palliser Triangle in an arid kind of environment in Western Canada. And the other thing is, like, optimal moisture can be a pretty elusive thing. And so just like a little graphic here, if you can think of this arrow as kind of representing an increasing amount of moisture, it's like, and I don't know how much of this is in our heads and how much of this is a reality, but it's like, here's too dry and here's too wet, and where we would love to exist is right in the middle there. And we might be, that's a fairly narrow gap, and in that little area, that's where we have to learn how to grow a crop and how we would prefer to grow our crops. So I think this serves as a bit of a theme to this presentation, and to what I wanted to frame up before we get into the kind of the more technical side of things. It's if we know that water is that important and we can't control it, and we know it varies over a season or over weeks, maybe we should think of ways or consider different methods of reacting to it. And I think that is a good way to frame up the discussion about measuring water-driven yield potential, measuring weather data, measuring soil moisture, putting it all together, and what we can do with some of that information. So getting into the meat and potatoes of this presentation, we're going to spend the next little while talking about measuring water-driven yield potential. I've got a few kind of pictures on this slide that represent, historically what that meant for us as farmers, right? It meant measuring what came out of the sky with a plastic rain gauge mounted somewhere in the yard, and it meant seeing if the surface had mud on it. And if you were like a real keener, you might even have a brown soil moisture probe that you would go, periodically, maybe a few times throughout the season, check to see how far you can get that into the ground. And that, that has been and currently still is measuring water-driven yield potential in Western Canada. So chatting a little bit about precipitation versus soil moisture, they're not the same thing, but they absolutely contribute to the same thing, and the ultimate goal there is getting water into our crops and the plants in those crops. Historically, measuring and interpreting available soil moisture was a challenge, and that is just a reality of dirt and soil. So soil's a three-dimensional kind of a thing, and it's hard to see. You can't see in the dirt. So as per usual, we've taken the path of least resistance and focused on what's comes out of the sky, because it was, it's been a little tricky to quantify what's in your soil. And I think we're probably have been guilty of considering soil moisture less important than rainfall. Again, due to those same reasons, we just paid a little less attention to how much moisture was in our soil. And I don't mean in that inch and a half when you're seeding. I mean 3 feet down. What's in that soil, and what is its ability to get that to a plant. I think some would suggest the opposite of that last statement is true. And so this is a quote that we sometimes refer to from Les Henry on this subject. And he says, water in the ground is like money in the bank. His point is like, you already got it. The battle of like hope, crossing your fingers and hoping it falls from the sky, you already won that. It's in the dirt. Like, you can count on that water. And I witnessed this firsthand in 2017. So I started as an agronomist in the Rosetown location, and we saw this in 2017. And I've got a little bit of data to display there, demonstrate this. So right now we're looking at some data. We've got some rainfall data that would have been informed by a weather station in Rosetown. So that's coming from the Environment Canada. And then I've got some yield data from the government of Saskatchewan, which would be informed by Saskatchewan crop insurance, which we know is infallible. So, my points here is in 2017 we received, less than average rainfall. I think it was somewhere in the realm of that station in inches was like around 4 inches of rain, and we grew the biggest cereal crop there that Rosetown had seen in 5 years. So how could that have possibly happened, right? The canola data, similar. It was by no means a crop failure in canola, but maybe bucked the trend a little bit. But yeah, and I don't know if that's more of a symptom of some of the resilience of canola, or even potentially some of the resiliency of some of the soil types around Rosetown. But the point being is we had the least amount of rain in the last 5 years, and canola was somewhat of a probably average to above average crop or year for canola, and the cereals was the best in 5 years. And that to me is no exception or no coincidence with the year that happened right before it, right, which was that 2016, where we received a substantial amount of rainfall, and so we had recharged our soil, and we grew pretty good crops in 2017 off mostly soil moisture. And that was an interesting thing to see firsthand. Okay, so switching gears a little bit to the actual technology here. So having just a bit of a definition to the hardware. So what makes this work for us is a Pessl weather station. So that's the above ground portion there. That's a company based out of Austria. So they're supplying the hardware for the sensors above ground. And the soil probe is actually a John Deere soil moisture probe. So we've got sensors for air temperature, rainfall, humidity. There's leaf wetness sensors. We've got in that soil probe, we've got a sensor at 10, 20, 30, 50, 70, and 100 centimeters. So that's 6 sensors along the length of that probe. And there, of course, is additional options available for things like wind speed, direction, solar radiation. There's quite a plethora of different sensors available. So in that picture, you can kind of get a feeling of what that hardware looks like out in the field. Here's a bit of a close-up of the soil probe, and what you're looking at there is really what we're gunning for. We want that soil moisture probe to be out in the middle of the field, perfectly in a seed row, and we want the roots from that crop to be growing in and amongst that soil probe, so we're almost observing those roots with this data, and I'll get into what that kind of looks like. Okay, a little bit of the software. So there's a couple pieces of software that kind of runs this, but in terms of the soil moisture probe, it's really informing a piece of software called Crop Intelligence, which was developed by the South Country, the John Deere dealership in the kind of southeastern part of the province. So there's a phone app and browser access. So it uses sensor data and 30-year regional weather averages to model crop available water and water-driven yield potential. So this informs the user on a few different things. So crop health, soil moisture, root activity, like I was just referring to in that last picture, and last but certainly not least, yield potential. So this is just a quick map of the crop intelligence enabled weather stations in Western Canada last year. So there's starting to be a fairly substantial amount of these stations. I think the number was somewhere between 750 and 800 out in Western Canada, even a few in Montana and the northern state there. So this is getting to be this company's seen a pretty substantial amount of growth in the last 3 or 4 years. Okay, so now I've got some screenshots to kind of demonstrate the actual deliverables of this software and what it looks like when everything's kind of put together. And that's really what crop intelligence is trying to be, a spot where all the data that is informing this model comes together and then presents it in I think a fairly nice and easy way for analysis for farmers and agronomists. So right now, this is probably the most widely used graph I would suggest in the system. And I'll get my little laser pointer out here. So this red line, I think, is probably where we should start, and that is displaying or plotting water-driven yield potential each day. So what we're looking at here is how water-driven yield potential is responded to this blue bar, which it represents a rain event. So we're gradually decreasing without rain. We get a shot of rain and water-driven yield potential jumps up and continues to go down until another rain event. So this blue bar at the top, it's displaying crop available water, and so we're also seeing how that's responded to a shot of rain there. And so if you held your mouse on this, if you were on the computer or tapped it up, if you were on your smartphone, it would show you each day what your water-driven yield potential and a few other things in there. But we're just going to focus on water-driven yield potential and crop available water at the moment here. So yeah, on May 27th, it is saying your water-driven yield potential is at 19.75 bushels an acre, and that is always in reference to the yield goal that was established for this field, and in specific the area of this field that station was installed in. And that is also an assumption, or the calculation that's taking place there is always assuming 100% of average rainfall from that day. And so it's also showing you at that day how much moisture is available to that crop. And so on May 27th in this field, there's 8.5 inches of moisture that's available to that crop. So this is an example where we are sitting in a pretty good spot with regards to how much moisture is in that soil and its effect on the yield opportunity for this is a cereal crop. I think this was durum in this field. Another little interesting application here is the some rainfall scenarios. So that number I just showed you, that is assuming 100%. So let's say from today, that grower received 0 rainfall. How would that affect their water-driven yield potential? And so this model is suggesting that from today, if this field received no rain, then the yield potential for this durum would be negative 20 bushels an acre of that yield goal. And I don't remember that yield goal. I think it's maybe 50 bushels an acre. So saying, hey, if you don't get a single drop of rain today, your durum potentially goes 30. If you get a quarter of the average rainfall, your durum potentially goes 40, right? And in this case, there's some pretty good moisture in that soil, which is something we never would have known without this. It's saying if you don't get, or if you get half of your rain, your wheat's going to go, your durum's going to go 50. So that's kind of what these rainfall scenarios are kind of informing us about. So now we're looking at probably the real magic of this software, and this takes a little bit of practice. I mean, I'll say full disclosure, the first time I looked at this, this meant nothing to me. However, I'm probably 3 years into this, and people that have been doing this longer than I, they can get a pretty good, impressive understanding of that soil just by looking at this graph. So what we're looking at here is the hard data from the soil moisture probe. So each one of those lines represents one of the sensors in that probe. And then those blue bars at the bottom again are representing rain events. Okay. So yeah, well, I mean, as the higher a bar is, there's more moisture there in that soil. And so there's quite a few things we can look at here, and I'll go through a little bit of kind of an example of what I'm seeing from the soil. So one of the things we can learn here is where the roots are, and we make that assumption when we start to see the moisture at a specific sensor depth start to decrease. Okay, and so I'll show this with this red arrow here. I'm pretty confident, I'm quite confident that the roots got to 100 centimeters in this field on August 10th. And this example is a canola field. And so we can see that 100 centimeter line is pretty flat, maybe recharges a bit, but those moisture levels at 100 centimeters don't start to move substantially, at least not down, until August 10th. So that tells me the roots of that canola plant started sucking up moisture at 100 centimeters on August 10th. Now we can go backwards from there. So at 50 centimeters, I'm pretty confident those roots hit 50 centimeters at the 25th of July. And same thing at the 30 centimeter sensor. Probably shortly before that, maybe 22nd, 23rd of July. Now, typically you can usually see that on the previous sensors, but there was like so much kind of rain activity and recharging going on kind of in the end of June, start of July. It's a little hard to see in this situation. But I'm looking at this station, and I know that that's actually late. Like roots taking till the start of August to get to 100 centimeters, or the end of July to get to just 50 centimeters, right? That's fairly late, and I'm wondering, what's going on there. And then I'm starting to recall that I think this area had received some hail, and I'm starting to wonder if what we're looking at is some delayed maturity. So taking a look at some other data now, these bars at the bottom of your screen there, that represents a change in moisture. So when those bars are down, there's been a net decrease in soil moisture for that day. When the bars are up, there's been a net increase. So when you see the bars go up, typically, right, that's going to be a rain event. We've added moisture to the system on that day. When the bars are down, we've lost. Now, in that blue bar that seems to be the longer one in each day, that's the sum. So we can kind of focus on that. Now, typically, when a canola enters the flowering stage, it uses a tremendous amount of moisture. Another thing we've learned here. That longest bar you see in this area, I think that was like 10 millimeters that day. I mean, you just think about losing 10 millimeters of moisture each day when that canola is in the middle of flowering. Anyways, from my experience, this would inform me when that canola was kind of in the middle of flowering there. And I'm just making that judgment or assessment based off how much moisture we were losing each day. And that looks to me like that field was, in heavy flowering at the start of August, which is late, right? I typically think of canola entering flowering at the start of July, right? So I would bet any money that there, in this area of July here, that there had been a hail event. Yeah, and so that's what kind of what I'm gathering from this data. Now, just to show you what a canola field without a hail event would have looked like using this kind of same process or thought process. This is a field that I know for a fact didn't receive any hail, and we're watching that big moisture usage, peak water usage kind of start. Well, it starts at the start of July and kind of tapers off with pod fill at the end of July. So that's more typical. So yeah, I bet any money right now we're looking at data that is suggesting a delayed maturity, a delayed flowering timing or season there. And yeah, so I mean, that's just a bit of an example of like some of the data, or some of the way you can analyze this data. And yeah, I'm not going to lie to you, it takes a little bit of practice. Like, are those lines telling you that there's lots of moisture or not a lot of moisture? Well, I can, I know that looking at those, like at the 5th of July, this field was full of moisture. And how you analyze that changes on the soil type. And so we've got some reference sheets and some cheat sheets and stuff at GMAX that can inform that a bit. But yeah, it's like looking at this data and getting some practice looking at this data, where, it's like, without sounding, I don't know, silly here, but it's kind of the first time we're able to have the roots communicate to us a little bit, right? Typically, it's a huge pain to be able to observe root activity without grabbing a spade and gingerly cleaning off dirt off roots and stuff. But this is kind of our first step in being able to observe what our roots are doing, and we know those roots are important. And in some cases, they might be more important than what we see above the ground. So there's definitely some applications looking at this data. We've seen where a frost can happen and you won't see roots move for 2 weeks, or we've seen even like some group 2 herbicide carryover, and it just stops this progression of roots hitting this sensor, roots hitting the next sensor, roots hitting the next sensor. So yeah, I think there's quite a bit of applications, and it does take a little bit of practice to understand how to look at this data. I would think of it as a soil test, right? First time I looked at a soil test, I didn't know what it was telling me, but with practice and practice, I can now understand quite a bit from a soil test regarding that soil. Okay, last screenshot of a few more pieces of data that this system will kind of show us. So after the harvest season, that soil probe and weather stations can stay out in that field for a couple more months and see if we can capture some fall rains. And so they've built some functionality about trying to aid in some next year plans regarding how much moisture is in that soil. So here we're looking at kind of a rating scale across the different sensor depths, and showing us how much moisture is where. And there's also some functionality on planting crops. So this is a wheat example, but they're saying, hey, this is 2019 data, of course. So it's saying, hey, for 2020, we know how much moisture is in that soil. And so if you received 50% of your average precipitation on a wheat crop, that would get you 38 bushels, right? And it goes up from there. If you got 100% of average precipitation, we're starting that year off with quite a bit of moisture, judging by what that probe has measured in that fall timing. Yeah, if you get 100% of your average rainfall, boy, there seems like there's enough moisture here for 71 bushels an acre. So there's some definitely some fall planning applications there as well. Okay, folks, we're in the home stretch here. So water-driven yield potential. So what? What do I do with this, right? Yeah, that's interesting that I could see if retroactively that I got hail, but I wouldn't have needed a weather station or soil probe for it to tell me that, right? So I've got this ordered in a bit of a list of like low-hanging fruit to more advanced, I think. So I think there's some real obvious approaches of what you can do with this data, and then I think it gets more interesting and more complicated as we go on. So the first right off the bat, well, having a weather station on your field is just the most accurate measure of your local growing conditions for that field, for your farm. Rain, temperature, humidity, leaf wetness, soil moisture, potentially others. I think there's some value just in not relying off an Environment Canada station or we have customers that vary quite a bit of distance between the most public access to a weather station. I think this is one of the lowest hanging fruits here of what we can do with this data. It's a tool in assessing when to go after additional yield, right? And so I showed you that graph of how much money it takes to invest in nowadays versus whatever 60 years ago. This is going to give us the ability to react to when we've been dealt a hand that looks like there is additional yield to go after, right? And a lot of that can be from a top dress applications. If I'm trending 20 bushels above my yield goal and it's the start of June or the first couple weeks of June, do I have enough groceries to capture that additional yield opportunity? Or do I need extra groceries, right? And so that usually lends itself into a discussion on top dress applications or foliar feeding. Is there potential for some phosphorus deficiencies if I'm, that's going to stop me from capturing that additional yield that Mother Nature has, given us the opportunity to go after. A tool in assessing when to protect yield, right? Boy, if I've got what looks to be like a bumper crop on my hands and I've got the moisture to do it, and those roots are at the depths of where I have the moisture in my field, yeah, well, maybe that is, to me, is a useful tool, and to start thinking through that fungicide application, or if we're battling in late season insects and potentially an insecticide application, growth regulators. Am I risking some lodging because I've got a substantial crop here? So I think that this is a tool in thinking through some of those decisions. A tool in assessing when to be cognizant of crop stress. So we've definitely seen, we've seen firsthand what drought can do to root activity, what frost can do. We've seen residual herbicide damage. So things like, applications which may compound stress symptoms. I think of a cereal crop. I think of a group 2 graminicides. They can be known for being a little harsh on the crop. If your crop is, if those roots are in dry moisture or dry dirt and they haven't moved in 2 weeks, do we want to, smack that crop with a Simplicity or Varro? We might not want to, right? There's copper and strobium mixtures. They can be kind of hot. Unfortunately, we've seen firsthand growth regulators in a crop that might be moisture limited or water limited can get the exact opposite effect of what we're looking for. So knowing if that crop is kind of in a stress state or not, I think is valuable. And like I just kind of talked about, a tool in assessing potential for next year. So is there fall or winter fertilizer applications? If there's next to no moisture left in that ground going into next year, does that impact some fertilizer applications or decisions on fertilizer applications in the fall or winter season? Seeding decisions, right? Does that infer a canola or a wheat decision, or hey, there's no moisture left, this is a good crop to put or a good field to put a pulse crop on. Okay, so then I think this is all great, but I get a little excited on some of the more deeper applications or analysis, and I certainly hope people smarter than me get their hands on this data for multiple years and find real in-depth understandings about their farms and their fields. So I think that through things like developing a baseline of crop available moisture information. So how much do you typically start that season with? How much do you end with? And then how does that compare across multiple years and seasons and crops? So these are very much like multi-year understandings with this data. What does 6 inches of soil moisture mean for your soil or crop or farm? What does 9, right? These are understandings, again, like I said, I think are kind of multi-year endeavors. What's normal root activity for your farm and your soil? And how does that compare across seasons or crops? How much can we affect root development through management decisions? Infiltration. How does rainfall affect your soil moisture on your soil types? Is that all the same across every soil type or in every farm and every field? I doubt it. Someone mentioned this to me. Hey, Bryden, could we learn the difference between what happens with a hard rain versus a gentle rain, and how big of a difference those two can be? Yeah, this is definitely a tool that could inform some of those understandings. Obviously we'd have to know a few different things. We'd slope and soil type and some different stuff can impact that. But that's an example someone mentioned to me, and I was like, yeah, I mean, this is the tool to be able to start thinking through those kinds of things. So yeah. Okay, guys, that wraps that up for me. So yeah, I appreciate everyone's time. Does it appear that we have any time left for questions? No, if not. Thanks again for your time. If you are wanting to learn more, just get a hold of me or someone at GMAX, and we can be in contact. So, all right, thank you very much.